going to see how the search is evolving into Elasticsearch and what next, right? I think some of you I already met on a booth, but who don't know me, I'm Ashish Tiwari. I'm a senior developer advocate at Elastic. What it means, I usually handle the community in India and help developers with their questions, whether having any doubts about the Elastic or anything about the technology, right? Sometimes I go to the clients and help them with their problem statement, how they can use the Elastic to solve the different problem statements, right? Got a fair number of years of experience in a technology. Started my career as a software engineer, then technical architect, then I'm working as a senior developer advocate. So, okay, let's move ahead. Wanted to get started with this question. So everyone is using LLMs, ChatGPT, and asking the questions, right? But who left Google search? Since these players are in a market and you can ask directly the questions. Still, the Google search is we need it, Stack Overflow we need it, or it's okay. Yeah, anyone who is not using Google search or Stack Overflow, right? Still, because we need I think search is the most important thing. Still, it's the most important, and it will be there, right? But yeah, before diving that, this is the agenda. We're going to cover the 4 major points. What is the challenges with the generative AI apps, LLMs, how you can solve with the RAG, and we're going to have a look on information retrieval, which is how to retrieve your context window, and why Elastic, right? But yes, as I said, search is more important still, right? Because why? Because you must have seen such news, right, on the internet, and still you must have experienced this. The LLMs can hallucinate you, right? Sometimes it's not accurate, especially when you're talking about some of the private data. Of course, it's not possible to talking with the private data. Question about the private data with the public LLMs, but yeah, there are the problems like the hallucination, bad answers. Of course, it's not have a real-time access exposure, right? So there's a security concern, privacy. You still there is a loopholes in that. So how you can solve all this stuff? Suppose you wanted to create a experience like a chatbot, ChatGPT kind of experience on your private data, which is sit in your database, right? It's possible with the help of a Retrieval Augmented Generations, right? So anyone who's working on a RAG? Okay, 1, 2, 3, yeah. Okay, I'll give you the what is a RAG. This high level is this is a typical flow. Okay, the idea is whatever the data you have, just dump into the data store. Probably is the vector store or something like this. So whatever the question you're going to ask, right? Suppose, what is GETS? Okay, this first question will go on your vector store, right? Or any DB, where it will give you the relevant result, right? Probably the 2 or 3 record or maybe a 10 records. Now, your 10 records will go as a context window into the as a prompt in prompt to the LLM, like a ChatGPT or any local LLM, Gamma or whatever you are using, and it will give you the answer, right? So this time the end answer you will get it will be the pure accurate and without hallucination, right? But how actually it works, we'll see. But before moving forward, who's working on Elasticsearch, using Elasticsearch as of now? 1, 2, 3. All right. I'll give you the quick overview. What is Elastic? So Elastic is the company behind the Elastic stacks like Elasticsearch, Kibana, Logstash. Right. ELK is one of the use case and pretty famous. We are solving a lot of problem statements. Suppose if you are dealing with the full text search, aggregation, geospatial data types, we got an analyzer. If you want to build something search engine around your local language, we got a language analyzer available, right? On the top of it, we have built the solution which is called observability, search, and the security. So if you want to enable any kind of the monitoring, let's say infra monitoring your code, if you're dealing with the containers, how my pod is doing, everything is possible with the help of the Elastic Observability. Search, you already know, search is, we are already there for the full text search, but yeah, right now this is semantic search is possible. We will be going to see in the part of the information retrieval, right? Apart from this, we also having RAG, and where you can import your own models, LLM model, and you can use it for to build the RAG system and to generating the embeddings. So yeah, get back to again RAG and why, where is Elastic fit into this? So Elastic comes in a picture when you have to retrieve the proper context window, right? Even if you are not getting the proper context, the proper data from your database, again, the LLM will hallucinate you and it will be the inaccurate answer, right? For that, you need a technology where it will pick a proper context. So this is where Elasticsearch comes in a picture. You dump your all data. The idea is you dump your all data, textual data, and perform the different kind of search. It might be a lexical search, lexical plus semantic search, just the semantic search, or the hybrid search. Everything is possible. So yeah, but let's see how things are working without RAG and with RAG. So suppose you are asking the question to the directly to the LLM, any LLM, or probably let's say ChatGPT, you might get an answer like this. Okay, this is a very generic standard answer, right? My laptop is freezing. How do I get a new one? This is one of the example. But apart from this, if I'm asking a question, my laptop is freezing. How do I get new one? Okay, and you first execute this question as a query into Elasticsearch. Elasticsearch will give you the proper context window, and then you pass it to the LLM, right? So Elastic brings a context, right? Generative AI with your data. So this is how it works. And I have also a demo. We're going to see how you can build a quick question answer capability on your private data set. I'm going to show you. So yeah, but the end, what is a prompt you can send to the LLM? This is just an example. You can anyways modify it, but this example I have taken is answer the question based on the following context, and the context is the data you have picked up from the Elasticsearch, the chunks, right? And the question is the same question which your end user has entered in the search bar, right? And you will get an answer like this. Okay. Now it brings me on the third part, which is important, is the information retrieval. So people who already know, already working on Elasticsearch, they are using lexical search very heavily, which is called term-based search, which is called token-based search as well. How it works? It works tokenizer, analyzer, and it insert into inverted index. So, for example, just take the jumping foxes is the one example. You apply some analyzer and tokenizer according to your use case. It will give you the proper token, right? Refined token. And this token is going to divide jump or fox into two token, the sentence, right? And it's going to store into inverted index. But what is the inverted index, right? So, suppose I have given the document 0. This is the document 1. This is the quick brown fox jump. This is the first record. This is the second record. And this is how your data is going to divide into tokens and is going to maintain the table into the inverted index. So suppose if you are, if you are searching for example, brown or dog, it will first look into the inverted index. It will find out, okay, which document ID is mapped with this particular token. It will fetch all the document, give you the result. So this is how the Elasticsearch is faster. This is because of the inverted index, right? Okay, now we have seen the lexical search. Okay, this is how right now, if you are searching on a Elasticsearch without semantic, this is how it works. But what is a semantic search or a vector search, right? It's not just a keyword, but it's the meaning of the keyword, and it's just a model and index, right? The simple things is, let's take the same example, jumping foxes, pass to the ML model. So we got a different ML model like the embedding models, right? Which simply converts your plain text to numbers, right? Which we call the embeddings as well, right? And index it. right? It is a decades of research, but very little optimization, and it will be tuned by the model. Okay, there is no human intervention with that. Okay, so again, how it works behind the scene. This is the first document I'm giving, and again, it passes to the ML model. This will generate the numbers for you, which is called embeddings. And this number is going to store into the vector values and the vector index. We maintain that as well. And this is how you can then perform the KNN and ANN searches, right? But, okay, it's a number, but what's in the vector, right? This is another question. So, whatever the model thinks is important, which means whatever the data it's been trained, that matters. It's going to generate the embeddings around that context, right? It's a fine-tuned foundation model. It could be and trained on a lot of general document and the query pairs. But vector are an approximation of meaning. There is no such things as an exact, right? You don't expect you will get the exact result. It's always the approximation, right? So now lexical search, it's a semantic search. Now the third one is, okay, there's an example. Okay, so how it really works, give you the visualization. Suppose on the left hand side we got some animals, on the right hand side the respective cartoons are there, and if I'm going to query on a elky, which is this animal, and it's going to give you the similar object which is presented into the same group, right? This is how you can build a recommendation system as well by using the vector search. It's going to give you the similar object, right? If you wanted to do the image search and audio search, that is also possible. You can convert your image into the embeddings, audio into the embeddings, dump into Elasticsearch, perform the KNN and ANN query, and it will give you the similar images. So we got a wonderful blog as well. You just search Elastic image search. You will get a link, and we got the all steps, right? Okay, now lexical, now semantic. Now we have a hybrid 101. Okay, it's as simple as it says. Just lexical plus a semantic. And both are generating the scoring. So if you are working on Elasticsearch generate the score for each and every document, which shows how well it's matching with your query, right? It is the same happens with the vector search. So you can combine both of the scoring, and you can get the best relevancy of the result, right? This is one of the example how you can do it. I have given the query match, which is the full text search, the summer clothes, and the respective vector search I am doing. And of course, you can re-ranking your result by using the boost, right? Okay, if you don't want to, so there is a RRF boosting as well. If you want to tune more your rankings, there is a manual boosting and RRF you can use it. Apart from this is the lexical, semantic, and hybrid. Elastic got the ELSER. ELSER is a sparse vector model, so which is nothing but the text expansion model. You give a text, sentence, or whatever you want to insert into Elasticsearch, it's going to generate the tokens around your sentence, around your records, right? And this token will be belongs to the same context. Maybe sometimes it's a synonym, sometimes it's the same context, right? And whenever you going to perform the semantic search, it's going to perform on these tokens by using the ELSER, right? All right, back to the RAG. Okay, let's try to build the Q&A on your private data. I have one demo ready, and we'll see how it works. All right, so this is the sample notebook, and it's a Python one, so I hope it's visible. Yeah, you just install these packages and import it. So I'm simply going to run it without taking time. I'm loading all my Elastic Cloud ID and the passwords and all those stuff, API keys, and the Elasticsearch index name I have given the gits RAG demo. So whatever my data is, I'm going to read, it's going to dump into the Elastic RAG demo index, right? So I'm just doing it. Okay, apart from this, I'm going to read one JSON file, which is here, and it is containing the workplace data. like your leave policy, how compensation works, what should be the sales goals and kind of that. Okay, and what we are going to do, consider this is your private data and we're going to dump this into the Elasticsearch. But before dumping that, we need to chunk this out. Okay, this is a one whole JSON document. You can't consider the whole JSON as a one document. So we're going to chunk this is the whole JSON document, and there is a different procedure for chunking, right? So you can choose the proper method according to your use case, right? So I'm going to load simply this and going to create a chunk. Here chunk size I have just taken the 50. So it's created the chunks, and let's insert the document. So so whatever the document I'm going to insert, it's going to pass from the ELSER model to this is the model ID which is running in my Elastic instance, and let's hit this. So I'm using the LangChain right now, but yes, you can perform or create a RAG without LangChain as well. But LangChain gives some of the good functionality, so you can quickly use it. Okay, this is just a show result function. So yeah, now let's search. Okay, here's my query, work from home policy, and I'm going to perform the semantic search on it. And it's giving me the 4 records, right? And this 4 record is the semantically matching by using the ELSER, right? Anyways, you can increase the number of the document you want to consider as a context window. That is up to you. Now let's add this is just a function for text processing. So add a context, and here I'm going to building a chain. So chain is this is my prompt, final prompt, which is going into the LLM, and for the LLM I'm going to use the OpenAI ChatGPT. So the prompt says answer the question based below on the following context, which I've given the example, and this context I'm going to replace with these 4 documents, right? And after that, the question is going to replace by whatever the question we're going to ask. So let me execute this, and let's ask a question. So, all right. When work from office is resuming. I know some people don't like this question, but let's see what we're getting. Okay. The RAG response is starting May 1, 2023, employee will require to work from the office 3 days a week, right? And this is the ChatGPT response, which is the standard one, correct? Let's verify whether it's giving the proper answer or not. I'm simply going to search on May 1. So yeah, here is my content, and it's giving me the right result, right? Let ask a couple of more questions. What is sales goals for 2023? And it's my private data. It's going to query on my private data. So yeah, the RAG response is the sales goals for 2023 are to increase the revenue by 20% and compared to the previous year and blah, blah, blah. But, and the behind is the ChatGPT is the general response. So yes, this is how you can build the question answer capability on your private data, right? This is the quick example I have given. Though notebook is available, you can use it. But yeah, this in that, this is how we are sending the prompt by replacing the context which we are getting from the Elasticsearch, right? All right. Now, the last point? Why Elastic? Okay, there is you can replace with any other store technology for a context retrieval. So Elastic has all capabilities. It is just not you need a vector DB. Only vector database is not enough to retrieval. Only full text search is not enough to retrieval. You need a hybrid search. You should able to tune it, right, according to your use case. So Elasticsearch gives you the all capability, the most vector database. It's like a vector database, full text search, everything is there. Apart from this, it's give the hybrid choice of flexibility embedding model. So you can suppose you don't want to use the public LLMs, right? You train your own model and you import into the Elastic ecosystem. So you can use that model for a generation and to talk to your data, right? Apart from this, the LSER is available, and there's a lot of things like autocomplete, and for the full texters, you can tune it the way you want, correct? So that's what Elastic give you the power to perform the search. This is the resource. This is the Elasticsearch labs we have, where you're going to find a ton of resources, the playbook, the notebooks, the integration with how you can build the RAG by using the Gamma, Gemini, and all those stuff. How you can do the vector search. So recently we also did a lot of optimization on a byte quantization and scalar quantization. You can go check the blogs. This is a collection of all the resources, right? With that, that's it for the day from my side. All right, thank you, folks.